Hey folks, how's it going? It's Mr. Murray coming to you with a short little video, hopefully on graphing systems and solving systems algebraically that involve circles and parabolas. And in circles, I also include semicircles, okay? So in this video, we're going to talk about now that we've solved systems of equations, like you might have done in 8th grade and maybe we touched on briefly in 9th grade, now we're going to solve systems that contain a circle and a line. So we could have a circle and a line. We could have a semicircle and a line. We could have a semicircle and a parabola. We could have a semicircle, or rather a circle and a parabola, a semicircle and a parabola. Different kinds of nonlinear systems. Now I know in the past we did nonlinear systems with like a parabola and a line. And we even looked at earlier a circle and a line. But now we really want to focus on multiple nonlinear systems or nonlinear equations at the same time. Okay, so when we do this, we're going to focus on solving it two ways: graphically and algebraically. Okay, and for the graphical interpretation, I have a little TI simulator here. This is actually the official SmartView software, so hopefully this one will run better and not crash on me. All right, so I'm going to jump in with our first system here. And we want to solve this algebraically and graphically, okay? So what we have here, I'm going to try to paint a picture here. We have x squared plus y squared equals 16, all right? At this point, we need to recognize, and I'm going to do my best to draw this, and it's going to be a little bit of a rough graph. It's okay if it's not perfect. We have a circle, and then what we have is we have a line, okay? And so what we need to be able to identify roughly is that there are two intersection points of the circle and the line. All right. Algebraically, we're going to determine exactly what they are, more or less. Might not end up being whole numbers. And then we're going to go ahead and use our simulator software to see what actually happens. Okay. So what I'll do is I'll start by solving this algebraically. And remember, the method that we're going to use is substitution. Okay, so y is equal to x plus 2. Okay, so notice I have x squared plus y squared is 16. So what I'm going to do is I'm going to do this. I'm going to keep my x squared, but now, since y is really x plus 2, instead of doing y squared, I'm going to take the x plus 2, and I'm going to make it y. I'm going to plug it in for y. All right. Now I'm going to FOIL this out. So when I FOIL or expand it out, I'm going to get x squared plus 4x plus 4. Okay, and if you don't agree with me, I would say check your work and maybe independently on your own FOIL that out. Is 16. Now we do have a common factor, or rather like terms of x squared. So I'm going to make that a 2x squared. Alrighty, and I actually got lucky. There's a common factor on each side of 2, so I'll divide everything out by 2, and I get x squared plus 2x plus 2 equals 8. All right, now I need to solve this, so I'll go ahead, I'll slide the 8 over, I'll subtract it from both sides. It's actually pretty good midterm review practice because we do need to know how to do this. Okay, so basically I need to factor this, and I'm not going to be able to in this case, so I'm going to use the quadratic formula. Again though, I would expect these kinds of problems to show up on the midterm, so it's actually good that we did this now because we get a little bit of recap on that. Okay, so we have to remember the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and I've got a is 1, b is 2, c is negative 6. So I've got negative 2 plus or minus the square root of 2 squared minus 4, 1, negative 6, all over 2. 2 times 1. Okay, let's simplify that. So I've got negative 2 plus or minus the square root of 4. This will turn to a plus. So it's 4 plus 24 over 2, which is negative 2 plus or minus square root of 28 over 2. And we can actually simplify that because 28, notice 28 divided by 4 is 7. Okay, so what that means is this is equal to 2 root 7. So it's negative 2 plus or minus 2 root 7 over 2. So I can do a little cancellation, and I get negative 1 plus or minus square root of 7 is x. Okay? So what does this mean? This means that I've now found my coordinates for x. And based on that, I now need to find y. Okay? So if x is equal to negative 1 plus root 7, well, I want to get specific here. Let's go back here. So let's just go back and fix that. Okay, so if it's, we either have plus root 7, and if that's true, I'm going to plug into the second equation to figure out what we got. So I'm going to take that and let's actually plug it in. So y, and I add 2, or it's equal to minus the square root of 7 plus 2, which means 1 plus square root of 7 or 1 minus the square root of 7, because you've got to combine this term, this term, this term, this term. Okay? Now, what does this mean? This means we have two solutions. Okay? These are not going to be nice numbers, but that's okay. So, I've got negative 1 plus the square root of 7, comma, 1 plus the square root of 7. And then I've got negative 1 minus the square root of 7, 1 minus the square root of 7. Okay, it's not going to be nice, and this should be reflected in our graph here. So these are the solutions, okay? And it's okay to not get nice numbers, right? We have to, at this point, accept that that's going to happen. Now to graph it. So what we notice here is that, remember, these are generally in a situation where they're solved for y. So this is not having y alone. So I'm going to go y squared, x squared plus y squared equals 16. We need to get y alone. So we subtract x squared on both sides. We square root. Okay. Now remember, as we discussed in class, this is only going to give you a semicircle. Okay, because remember, only positives can come out of square roots, or I guess 0. So we're going to do this one in here. We're going to define y2 to be the opposite, because this will result in a reflection that gives you the second part of the circle. And then we'll do y3 is equal to x plus 2. So let's go ahead and plug that in. Okay, and I'll do this with my mouse. So we have square root 16 minus x squared. We have negative, make sure you use the right negative, 16 minus x squared. Then we have x plus 2. Let's try to graph this. Okay, there's the top half of our circle rather. There's the bottom half of the circle. Here's a nice beautiful line coming in. Now remember, the intersection points, extremely important. Step 1, I'll maybe write this down. Remember, to do the intersection, step 1, second plus trace. To go to the calc window, and then we need to do intersect. Okay, so here we go. Second, trace, go down to intersect, or just press 5. Okay, we need to select the first curve. So note that the color of the graph is the color of the text. So if I want to make sure this is the top one, Notice that blue color text, blue color graph. Enter. Now, I want to select the second curve, so I want to select the black colored text. And now let's find the intersection point. I'm going to press this left arrow until I get about there. And I have 1.64, 3.64. Okay, notice there's really common decimals. So let's see if I was actually right. So here what I'm going to do is, this is the first intersection point. And I know that because of the plus. So let's do -1 plus the square root of 7. Okay. And let's see what we got. So it's about 1.64 and some stuff. And if we actually get an exact first curve, second curve, guess, right? We actually got it pretty good. 1.6475, this one. Yep, perfect. So that agrees with what we've seen. So what we would do is, I'm going to just go ahead and get that intersect one more time. So first curve, second curve, navigate to the black graph, guess. Okay, I'm going to come back over here. I'm going to round to the nearest hundredth. That's okay. So we're going to write 1.6, let's call it 5, 3.65. Notice how this is 2 more than this, because it's literally x plus 2. The y is 2 more than the x, so that's what we should get. Now the second intersect, same idea, trace, but now it touches the red line. So first curve needs to have the red text, or whatever color matches the second graph. Second curve, good, black. And just try to get it close. It doesn't always have to be perfect, but sometimes you will get an error. Okay, nice. So now we have -3.64, negative. So notice how, again, the y is 2 more than the x. That's definitely a very good sign. It's the opposite of this, which is what we should expect because the signs are flipped. That's a good sign as well. So I'll come back over here. -3.65, -1.65. All right, and that's how you do it. So we have the analytical solution. This is the more accurate. Yeah, I'd say more accurate because we have the exact values. This is how we plug it in, getting us the circle, the line, and the points rounded to the nearest hundredth. So this is what I expect. I want to just make this clear when you do these kinds of problems. Algebraically, I want it solved through x and y, listing the points. Okay, saying this is x, right? So this indicates which is x and which is y. Graphically, I want a rough sketch. Rough sketch is fine as long as it's reasonable, right? Okay, you need to, for example, show me that the y-intercept is clearly not 2. The circle, that's a reasonable x-intercept. That's fine with me. And if reasonable y-intercepts, etc., I need to see the intersection points and I need to see coordinates. Okay, so go ahead. I know it's definitely a pretty lengthy explanation. If you need to go back and kind of digest any of this, I encourage you to do so. And then in a second, I will move on. All right, here we go. Now I'm going to solve this next one. So here, again, circle. We can tell that it's centered at 0, 0 based on the x squared plus y squared. And we're looking at a radius of 5 because 5 squared is 25. So I draw my rough circle. It's all right. Here I've got a parabola. Okay, now if I get y alone here, I can see it's y equals x squared minus 2. So what I'm going to get is I'm going to get a little parabola. Okay, now I know it doesn't touch down here because this should be -2. Whereas this should be -5. So I know there's not going to be touching there. That's perfect. But it looks like I might have 2 intersection points here and here. So here we're going to solve analytically. To solve analytically, I am going to keep this, but I'm not going to do it like this when I solve analytically. Now notice, I have an x squared. If I could get the x squared alone, I could just do a direct substitution. So what I do is I add the y on both sides. And now look, x squared is y plus 2. So on the top, instead of writing x squared, I'm going to write y plus 2, right? Because if x squared is y plus 2, then I can make that substitution. All right, now I combine like terms. Y squared plus y plus 2 equals 25. Right, I make the right-hand side equal to 0. Okay? And this is what I got. Now I can tell right away it's not going to be factorable. I know that because I can't factor it because two numbers that go into 23, that's going to be pretty tough given that 23 and 1 makes 23. So I'm going to have to go in, and again, quadratic formula. Okay? So I've got A, B, C, -1 plus or minus the square root of 1 squared minus 4, 1, -23. I know I'm going to have an answer because, or a real answer, because this will flip to a positive. Remember, if you get a negative in the square root, that means you're going to have complex solutions, which means no real solutions, which means no real intersection points. And remember, we're on the real plane, okay? So now what I'm going to do is I'm going to simplify. So I've got -1 plus or minus 1. And let's just go over here since I've got my fancy schmancy calculator. Clear that out. Right, because if we're on a quiz or a test, in this case, we're going to have a calculator. All right, so 1 plus 92 over 2. Not going to be easy, that's for sure. 93. 93 is not going to divide by any perfect squares, right? We could try 93 over 9 is not going to work. 93 over 16 is not going to work. 93 over 25. Yeah, this is going to be challenging, but that's all right. So what we have is -1 plus or minus the square root of 93 over 2. Okay? Tough to do, but you know what? It's all right. So here's what I have. Come back up, and we'll get ready to state our solutions. So, first one, -1. All right. Plus, oh, and remember, this is a y, so we have to be aware of where we're putting our coordinates here. Okay? -1 plus square root of 93 over 2. -1 minus, okay? It's really important to notice this. It's really important to make yourself aware that you have to have both of those roots, okay? Because in the end, you have to account for everything, okay? Everything has to be accounted for, okay? And let's see if we can see before we state it out what this is going to look like. I'm interested to see what this is going to look like. No, we can finish solving it out. So again, just to recap, I got my x squared alone. Okay? X squared equals y plus 2. I did the substitution. Right? I got the -23. I then did the quadratic formula. And I was good to go. All right. Now, we have to be careful here because now we need to solve for x. But again, yeah, let's take a look at what this looks like. So, remember, I'll just fill this in. All right, now remember, what we want to do here is we need to envision this. And remember, we're going to have y1 equals 25 minus x squared y2 equals, and y3 equals x squared minus 2. See what that looks like. So I'm going to take my 16s. I'm going to replace them with 25s. In this case, I get to be lazy because I already have a setup here. Here, I'll clear this one out. It's nice using this software because I'm not getting some of those crashes like I saw in my other video. Alright, let's envision it. Boom. Top circle comes in. Bottom of the circle comes in. It's nice and connected. I like that. Check out our parabola. Wow. Alright. So, folks, this is basically what we've got here. Now, we have two intersection points here, right? And the intersection points are pretty important in terms of figuring out what we got going on. All right? And so we need to find the x and the y, but see how it looks a lot like what we've got going on in this graph right here. And that's pretty important. Okay? So when we think about how this is going to work, we now need to plug in to the y to figure out the x. Okay? Pretty important. And so what we want to do is we got to figure that out. Real quick, I'm just trying to verify that this is all going to work out, because I'm noticing 1 minus square root of 93 over 2 is going to be a negative number. I wonder what's going to happen when we do this. So let's go ahead. Now, I now need to solve. So I don't necessarily have my points yet. I want to be careful here. I need to solve for x, okay? So when y is a negative number, right? You think about this. We're going to have a problem here. And here's why. Let's go ahead and plug these numbers in. Okay. So what I'm going to be doing is I'm going to be plugging in and solving for y, or for x in this case, rather. So we've got negative 1 plus 93 over 2. Remember our formula, equals x squared minus 2. Now, this is a positive number, so I'm actually going to be okay. But notice what happens here. So, first thing I'm going to do is I'm going to multiply both sides by 2 because I don't like this fraction. Then I'll add 4. Then I'll divide by 2. And then I will square root. This is going to work out, and I know that because this is a positive, this is a positive, that's a negative, and I'm going to get plus or minus this. And it looks complicated. I'll tell you this. This is more complicated than what you're going to see on a quiz or a test. Okay? But notice, when I do the negative, what would happen if it was a negative? Okay? This number here is clearly a negative number. Okay? And it's a negative number. Watch this. So I've got, when I do the same thing, I get negative 1 minus the square root of 93 equals 2x squared minus 4. So I add and I get 3 minus root 93 equals 2x squared. This is a negative number. We know that 93, well, look, square root of 93 is more than 81. So this is at least 9. So this is a negative number. It's not going to work out. When we square it, this is extraneous. So what we're going to do is we're going to throw that out. We're only going to keep the positives. And then we're going to have our two x's. So it's going to be positive 3 plus root 93 over, we said what, 2? And this one's going to be minus the root 93 over 2. So complicated answer. I promise you more difficult than what's going to be on the test. Way more difficult. Okay? So let's go ahead and now that we have these points, try to figure them out. So I'm going to go second, trace, intersect, option 5. Here you need to be careful. Okay? So, first curve. Second curve. Again, select the black curve. Here you need to be careful because if you don't get it lined up correctly, there's actually 2 intersection points. And remember, if you're plugging a number into a calculator function, only one thing can come out. Okay? So here what we get is we get 2.51, 4.32. Okay? Over here, let's try it again. Trace, intersect, first curve, second curve, guess. Okay? Nice. So negative 2.51, 4.32. Now, I'm not going to plug in to show whether these numbers really work. That would require a lot of calculator work. But notice that there are some good signs. 1, these are both the same. Pretty good sign. Now, again, we know it's a little bit more than 9. So this is going to be about a little bit more than 8. And we divide a little bit more than 8 by 2. We get a little bit more than 4. That's a good sign. These are the same. These y's are the same. That's a good sign. These x's are opposites of each other, which is also a good sign. All right. So look, definitely a difficult example, but here's what we need to know how to do. We need to know how to isolate a letter. We need to know how to plug it into the other equation. We need to know how to solve for the, whatever letter is left. We need to know how to plug back in and get an x and a y. I'll tell you on the test because I have done it. It will be more clear cut, but the ideas are the same. Okay, so if you need to, go back and rewind, make sure you understand it, and then in a second, I will move on. Okay, solve algebraically and graphically. Again, this is, as we've seen, a semicircle, okay? So let's hook this one up. It's a semicircle. So it's the top half of a circle. With a radius of 3. Okay? This is a line, right? It's x equals 2y, or in other words, 1/2 x equals y. So it's this goes to the origin. But notice, as a very, very intuitive thinking student today pointed out, there's only one intersection point. Right? We only have the top half of the circle. And so remember, this is a radical equation. So we need to be on the lookout for extraneous solutions, okay? So it's really important that you remember how to solve radical equations, okay? Here's what I'm going to do. In a second, up top on the screen, you're going to see a link come up to my video that I did on radical equations. Should have one. Please check that video out, okay? I need you to know how to solve them. It's really, really important how to solve radical equations. So make sure you understand how to solve them. And if you don't, you need to go back and recap that, okay? All right, so now here we go. X equals 2y. I have that relationship. Notice I have an x squared here. So if x equals 2y, I want to make a substitution. So how am I going to get this to be x squared? I'm just going to square both sides. X squared, 2y squared. So x squared equals what? 4y squared. So here I go. I make my substitution. Because x squared is the same thing as 4y squared. Now I square both sides again to cancel the radical. And this is where the extraneous solution comes in. So now I'm going to add 4y squared. Because what I've done is I've created, by squaring, you've created an equation that can have up to 2 solutions in it. But here's the thing. Just because I made two solutions doesn't mean that both solutions are going to actually work. So let's see what happens. So I'm going to divide by 5. I'm going to get it 9/5. I'm going to square root both sides, and I get y equals 3 plus or minus over the square root of 5. And I need to rationalize the denominator. So I get plus or minus 3 root 5 over 5. That's my y. Okay? Now, here's what we know. If this is a negative, if I plug this negative version back in, well, only positives or 0 can come out. So the negative is extraneous. So the only y that can be a candidate is positive 3 root 5 over 5. Again, because if you were to plug negative back in, no matter what you plug in here, you're never going to get a negative number coming out, right? When we graph it, we're going to see only the top half. And on the graph, you can see intuitively, you're never going to have a negative y intersection point. So we're going to throw that out. It's going to be extraneous. But now we're going to solve for x. Okay? So x is equal to 2 times y. Perfect. So that means x is equal to 2 times 3 root 5 over 5. In other words, x equals 6 root 5 over 5. And that is all she wrote. Now, I do need to now plug this in. So my y1 is going to be equal to 9 minus x squared. My y2, I'm just going to borrow from here, is going to be 1/2 x. So let's go ahead and do that. I'm going to just quickly turn that off. Hopefully that means that won't show. Follows well. Delete. Got a 9. Come down to the last one. Oop. Clear it. And I'll put my 1/2 in parentheses just to avoid any kind of PEMDAS errors. See what it looks like. Top. Beautiful. Okay. So I'm going to zoom in. Let me try that again. Zoom in. See if we can get a little bit nicer view. Oh, that was not so nice. See if we get the intersection point. We just missed it. All right, I'll go back to the standard zoom. All right, beautiful. So here we go. Kind of difficult to see. You might have to squint your eyes a little bit, but we do have a little intersection. Let's see if we can find it. So second calc, intersect, curve 1, curve 2. Let's see if we just guess right away. Boom. Very, very nice. So notice, good signs here. Notice that the x appears to be twice as large as the y. We know that. So we have an x of 2.68, a y of 1.34. Beautiful. And we could actually test this out. What is 3 times root 5 divided by 5? 1.34. Nice. Okay. And if we double that, we would get 2.68. Okay. So hopefully that made sense. Hopefully you found this a little bit less challenging than the last one. Go ahead, take a second, make sure you understand how I got this, and then in a second we will go ahead and move on. Alrighty. Now I'll clear this out, and we're looking at another one here. It's going to be a semicircle and a parabola. Okay, I can tell that here. And we're going to have intersection points up to 2. Let me just do that in a different color. It never wants to go back. It never wants to backtrack my work. I will save that one for later. I don't know why Smart Notebook's being finicky with me tonight. It's giving me a hard time. All right, that's all right. All right, it's not a great graph. It's whatever. It's okay. I'm looking more. I mean, if it's a pencil graph, I'd probably be looking for a little bit more accuracy there. But this is just a rough graph. We see two likely intersection points here. We could technically have three, except for the fact that it's not a circle, so we're not going to get a touch on the bottom. Let's try to solve it analytically. So take a second. We'll do this together. Think about which equation would I start with, and which letter should I start by getting alone. I'm going to start on the bottom. I'm going to get x squared alone. Okay? Graphing these is going to be a little bit easier because they're already both solved for y. So in the second one, I'm going to add 2, y plus 2 equals x squared. So now I can say y is equal to minus. So in other words, y equals 16 minus y minus 2, which is the same as 14 minus y. Okay, now I square both sides. I get y squared equals 14 minus y. So y squared plus y minus 14 equals 0. Now I need to see if I can solve this. Factoring is not going to work. Completing the square is highly not recommended. I'm going to do the quadratic formula. So y is equal to -1 plus or minus the square root of 1 squared. I know I'm going to get a nice number because this is negative. It will have solutions. Minus 4 times 1 times -14 all over 2. Okay? Now, I'm going to go ahead and solve this. So I've got -1 plus or minus. Right? We come over here. How about we do 4 times 14? 56. So 1 plus 56 divided by 2. Alrighty, and what we get is 1 plus or minus 57 in the root over 2. Alright, -1. And there we go. I can't simplify 57 anymore. Not divisible by 9, 16, any of those, so we're going to have to leave it. That's alright. 56 would have been nice because that would have been divisible by 4. That's all right. Now, I got to come and I got to think about this. Hold up. All right. Here's the problem. We know that none of the intersection points are negative. We can see the intersection points are both going to be positive. Even if the parabola graph was wrong, we know the semicircle never attains a negative value. So what that means is we're going to throw out the negative. We're going to throw out the negative. So we only have the positive. Okay, so we know there's two intersection points. 1 minus square root of, or 1 plus root 57 over 2. And 1 plus root 57 over 2. Okay, now, x's. I need to square this. I need to subtract 2. Okay? So, x, y, so we know y equals x squared minus 2. So here's what we need to do. Y is -1. I need to make sure we have the -1 there. Y is -1 plus root 57 over 2. So now what I do is, again, I'm going to multiply both sides by 2 because I don't like fractions there. 1 plus square root of 57 equals 2x squared minus 4. I'll add on both sides. 4, I get 3 plus 57 equals 2x squared. So 3 plus 57 over 2 equals x squared. So x equals plus or minus the square root of 3 plus root 57 over 2. Again, not a nice one, but that's okay. not one likely to show up, but it's good to know how to solve them. Okay, minus root. So again, all we did is we got a letter alone, we substituted, we solved, throwing out the extraneous solution because, again, the negative couldn't go here. That's not going to work, and we can see there's not going to be a negative intersection. We plug back in, we solve for x, get x alone, basically using square roots, and we solve. Okay, now lastly, I'm going to show our intersection. So just a quick tip, if you go second, delete, you'll actually insert. And so what that lets you do is that lets you insert numbers without like overriding and deleting. Okay, that's a little technique I learned there. I mean, I don't really care about the 25 being there. That's fine. X squared minus 2. Generate the graph. Here's our semicircle. Here's our parabola. Beautiful. So pretty accurate. Now let's do our second trace. First curve, second curve. Make sure we have the guesstimate because, again, you can't just mash enter here because there's 2 and it will give you an error. Okay? Nice. So I have 2.29. 3.27, and let's just, it should be the same y but a different x. Let's see what happens. 5, curve 1, curve 2, guesstimate. Remember, we have to get it close to the other one or it's not going to work. Okay, good. Negative 2.29, positive 3.27. Good. So opposite of x, same y. That's because we have the symmetry that makes that happen. Okay, so folks, I hope you found this video to be informational. I do have a last one that I encourage you to try. Okay, I do encourage you to try this on your own. I'm going to not cover this on the video due to the current length of the video. But here's what we need to know. 1, you need to know how to solve a system algebraically by using the method of substitution. Getting a letter alone, plugging it into the other equation, getting a solution for y or x, one letter, plugging it back in, getting the solution to the other letter. It's more difficult in this context because now you're not dealing with linear equations anymore, but the ideas are exactly the same. All right, in doing this, we need to look out for a couple things. 1, the need to use the quadratic formula to solve quadratics. 2, any skills related to solving radicals, including looking out for extraneous solutions. Okay. Once we have our solutions for both letters, we need to know how to, 1, plug into y equals. Remembering for a circle, if this was a circle, I need the root. I need to solve for y and then do the root and its opposite. So that's what the circle would look like. So we do the square root by getting y alone in the opposite. And then I need to be able to draw a relatively accurate graph, not perfect, but reasonable guesstimate. And then I need to be able to use second, trace, intersect to find the intersection points of the 2 curves. Okay, again, using the color of the curve, matching with the text color, and then remembering that you do often need to get a pretty close guesstimate and then rounding to the nearest hundredth. Okay, so I hope you found this video to be informational. Hopefully you were not too intimidated by some of the difficult radicals here. Please keep in mind, I did do the unit test. I did check the answer in the unit test. I do know that the answers are not going to be crazy roots, but you need to be able to navigate any kind of situation. Okay, so just keep it up. Stay positive about all this math process, okay? And remember, in the end, you can do it, okay? Thanks for tuning in. Have a wonderful night. Don't forget to love math.